Our project is on multi-level inverter which aims at the simulation study of new neutral point lamp PWM inverter. In this project, we can observe the differences between two-level inverter in parallel with multi-level inverter as well as the working operation and why multi-level inverter used over two-level inverter. Before going with multi-level inverter, let us understand about inverter and its type. An inverter is an electronic device that converts direct current to alternating current. It is commonly used in various applications, including power supply for electronic devices, solar energy system, uninterruptible power supplies, and motor drives. Inverters are essential for scenarios where AC power is needed, but the available power is DC. They function by changing the electrical polarity or switching the voltage levels to create an AC output from a DC input. In household applications, inverters are often used to convert DC power from batteries or solar panels into AC power to run the appliances and electronic devices. There are different types of inverters. The first one is two-level inverter and the other one is multi-level inverter. Let us understand about two-level inverter. Two-level inverter. What is two-level inverter? The two-level inverter is a type of power inverter used in electronic system to convert direct current to alternating current. It operates by switching the DC input between two voltages, typically the positive and the negative voltage. This results in a square wave or modified sine wave output. This is the basic systematic diagram of a two-level inverter which is connected to an induction motor. This two-level inverter is a combination of control circuit, power circuit or main circuit, and this is one of the application that is used with an inverter. The control circuit mainly consists of repeating sequence which is also known as carrier signal, and this repeating sequence the triangular wave is taken. Sine wave is also known as modulating signal, and these are the relational operators, and these are go to blocks. Go to blocks is used to pass the input to the corresponding block, and logical operator blocks are used to perform the specified logical operation based on the input. And this is the main circuit of a two-level inverter. That main circuit consists of DC voltage source to produce the three-phase output voltage with a two level, and series RLC branch is used as a RC filter which is used for filtering of harmonics in the generating current, and IGBTs are used as a switching devices to perform the required operation. This is the application of a two-level inverter. These blocks represent the asynchronous emission, which is the type of squirrel cage induction motor. These are the output waveforms of a two-level inverter which is simulated with an induction motor. The first waveforms represents the current, and these represents the phase voltages of three phase with two levels, and this is a dark waveform of a two-level inverter which is simulated with an induction motor. By observing these all waveforms, we can clearly estimate that the harmonic distortion in the two-level inverter are higher. So to reduce this harmonic distortion, we are going with a multi-level inverter. The another type of inverter is a multi-level inverter. What is multi-level inverter? A multi-level inverter is a type of power inverter that generates an output waveform with multiple voltage levels. This is in contrast to traditional two-level inverter that produces a square wave or a modified sine wave. Multi-level inverters are designed to achieve a more sinusoidal output waveform, which has several advantages by reducing harmonic distortion which is developed in the two-level inverter. There are two types of multi-level inverters. First one is neutral point clamp PWM inverter. The other one is cascaded H-bridge inverter. In this, we will discuss about neutral point clamp PWM inverter. A new neutral point clamp PWM inverter is a topology that is used in the multi-level inverter. This figure represents the schematic diagram of a new neutral point clamp PWM inverter which produces three-phase output voltage with a level of three levels. The main circuit of new neutral point clamp PWM inverter indicates the neutral point with respect to the DC source, and each leg of the NPC inverter consists of four transistors, namely S11, S12, S13, S14. The another leg of NPC inverter is S21, S22, S23, S24, and the third leg of NPC inverter namely represent as S31, S32, S33, and S34. Coming to the main transistors and auxiliary transistors, the upper and the lower, which are nothing but S11, S14, S21, S24, S31, and S34, are the main transistors operating as the switches for PWM. Remaining switches, which are nothing but S21, S13, S22, S23, S32, and S33, are the auxiliary transistors which are used to clamp the output terminal potentials to the new neutral point potential. Now coming to the working operation of new neutral point PWM inverter, the basic operation is when the IGBTs S11, S12 are turned on, the output voltage will be plus VDC. When the motor IGBTs S12 and S13 are turned on, the output voltage will be 0. And whereas S13 and S14 are turned on, we get the minus VDC. In this way, we will generate the levels of output voltage by using 4 transistors in each leg. Now let us see the simulation of its new neutral point clamp PWM inverter. This is a schematic diagram of a new neutral point clamp PWM inverter which is connected to an induction motor which generates the 3 level of 3-phase output voltage. This new neutral point clamp PWM inverter is a combination of control circuit, power circuit or main circuit, and this is the application that is used with an inverter. Now let us discuss the components or the blocks that are used in the control circuit. The first one is a repeating sequence which is used for the carrier signal uh, to generate the PWM waveform, and the other one is the sine wave which is used as a modulating signal, and these are the relational operators blocks, and 210 are the constants that are used for the relational operators input, and OR gates or the logical operators that are used in the control circuit to operate the logical operation. R1, R2, R3, R4 are the go-to blocks that is used for the passing of signal from one circuit to the another circuit. Now let us discuss the main circuit components or blocks. The main circuit consists of DC voltage source block which is used to produce the output voltage, and series RLC branch is used as the RC filter which is used to reduce the filtering of harmonics in the generator, and R1, R2, R3, R4 are the from blocks which is used to access the signal from the go-to blocks. And in this main circuit, we require 12 IGBTs which is used as the switching devices and 6 diodes. These IGBTs are used as the switching device in the inverter. And the application that is simulated with the new neutral point clamp PWM inverter is induction motor. So this inverter is simulated with an induction motor which is a type of squirrel cage induction motor. Now let us see the output waveforms that are simulated by using the induction motor. These are the output waveforms that are generated by the new neutral point clamp PWM inverter which is simulated with the application of induction motor. The first waveform represents the current waveform of induction motor which is generated by the inverter. This waveform shows the 3 phases of 3 levels, and these waveform represents the turn characteristics of an induction motor. These waveforms are the 3-phase output voltages with 3 levels that is generated by an inverter: R phase, Y phase, B phase. Now let us compare the output waveform of both the inverters parallel. By observing the current waveform of both inverter, we can say that the harmonics that are produced or that are raised in 2-level inverters are eliminated in the multi-level inverter. Similarly, in phase voltage waveform also we can say that the power that is improved by increasing the levels in the inverter that is produced by a 2-level inverter. Here the levels of 2-level inverters are 2 levels and the levels of multi-level inverters are 3 levels, which is nothing but we are bringing the output waveform nearer to the sine wave which is used to improve the power quality of a inverter. At last, by observing the dark waveform, we can conclude that the total harmonic distortion is reduced in the multi-level inverter, which increasing the efficiency of the induction motor than that of the 2-level inverter. In, in this, we can say that the 2-level inverter has more harmonic distortion, whereas in the multi-level inverter, we can say that the harmonics are reduced, that is, that are eliminated in the multi-level inverter. By observing the results, we can say that the current triple, dark triple transient peak time settling times are higher in two level, whereas in multi-level they are modified or eliminated. We can simply say that the current triple, dark triple transient peak time and settling time are reduced. Since by observing these values, we can say that output voltage is improved in the multi-level inverter, which brings the desired output. By this, we can say that in multi-level inverter, there is a low THD in output voltage, reduced switching stress on devices applicable for high voltage application. High voltage levels are produced, lower switching frequency can be used, and hence reduction in switching losses. And this is an reliability operation. So that's why we are using multi-level inverter than that of a two-level inverter. Thank you.